So my name is Jeff Levin. I'm based in Anchorage, Alaska, and the talk was originally going to be on building production web services, but I actually wanted to step back for a minute and talk a bit more about my personal story of becoming an engineer, mostly because it's gotten me all connected with you in this room. So you might be wondering, how does somebody from Anchorage, Alaska end up in Sydney for a tech talk? Well, 24 hours of flight time, 28 total hours in airports, one lost bag. But also, I run a developer community back home. And so getting to come to these conferences and connect with other like-minded people has been absolutely eye-opening. In 2018, we had 2 developer groups back home. They were in different cities that are about 6 hours apart. One of them had almost died because it lost its meeting space, and the other one had pretty much flickered out. And so I started working with developers back home, and honestly, I thought I was going to leave tech. I was not sure if I wanted to continue being a programmer, but as I started working with people, I got reinvigorated to become an engineer again and start learning and programming. And so coming to these conferences has had a really big impact on me. So this talk is as much about philosophy of being an engineer as it is about code, about Go specifically. So what happens when your workload doesn't scale with your framework? What happens when you use an opinionated framework and people don't read the opinions? And as we go on, every time you see this emoji exploding, I want you to yell, "Bear!" And I'm going to give you an Alaska Developers Alliance laptop sticker. So I also want to say this isn't a knock on any framework. Frameworks have a time and a place. We just need to make sure we're using them at the right time, and we know when to move away. And so this is about my journey of playing with Microsoft Front Page and PHP and MySQL at my parents' house at 15. In 2008, I went into computer science, and back at the college at home, you're writing handwritten tests in Java. Does anyone remember those? Like pen and paper, like you can't even use a computer or syntax highlighting? Ugh. So in 2009, I actually made the switch to management information systems at my university, which really preps you well for being a web developer. And I did my senior project in Ruby on Rails. I tell you what, I fell in love with it. I thought it was the greatest framework ever. And so from 2012 to 2017, I ran my own consulting firm. I was writing a lot of Rails, doing some WordPress, doing some Meteor.js. But this taught me a lot about project management. And what I've realized, and there's a ton of writing about, is that code is very expensive. After 29 years in the industry, sorry, this isn't my quote, but after 29 years in the industry, I can say maintenance is 60 to 80% of the total cost. Development is at most 20. Oh, that hit home. So how are the decisions that you're making with the frameworks and the tools that you're using going to affect the lifestyle of the projects that you're working on? So I'm, 7, 8 years into my professional developer career, and I'm running into this problem where I'm running a consulting firm. I'm able to make a living. I'm a shop of one. And I'm hitting this problem where I can't remember what the code that I'm doing or that I wrote is doing. Like within, 3, 4 months, I'm leaving notes to myself that in this case are longer than the actual code that's being written. And some of that, is misuse of the framework. Maybe I hadn't spent enough time studying what these things were supposed to be doing. But I'm also starting to feel like, there you go, photo op. I'm also starting to feel like, just what I'm doing and what I've been doing for so long isn't working. And this was kind of ironic because Rails is a really opinionated web development framework. And this quote, I wish I had read the documentation earlier. The hard part is knowing when to stray from convention. When are the deviating particulars grave enough to warrant an excursion? So I love Ruby on Rails, but the deployment of the applications was starting to get clunky. I was realizing that all of the solutions that I was writing didn't make sense to fit into this framework. And with the specific project I was working on, I was going to have to move into microservices, which was terrifying. So just a quick show of hands. Who knows what Ruby on Rails is? All right, awesome. So there's a few key things. It popularized REST, which I was actually really surprised about this, but anybody here for some trivia? When was the REST idea released into the public? 2000. That's funny. He actually gave me that fact yesterday. So the main tenet here is that Rails, the claim to fame was convention over configuration. And there was a term that they used, which is omakase, which is chef's choice. So they're making a lot of these common decisions for you so that you don't need to think about it and you can focus on business logic. But as I'm explaining, like, what happens when the decisions that you need to make, you don't have enough info to make? Or they don't quite fit into the paradigm, so you start leaving yourself paragraphs worth of notes to hope you can piece that back together a few months later. So I started looking at what is an actual web request. And this is funny, right? I've been a web developer, for 10 years, and I have never actually looked at what's happening in a request. And so, in fairly straightforward terms, you've got a computer, it's a client, you send a request to a server, you connect, they send you a response back, and in most of the cases, we're looking at doing requests through a web browser. But we can actually just test this stuff pretty straight up. So let's just do a quick, is that large enough? All right, so let's just do a quick curl request to Google, and we can take a look at this. All right, so all we did was we said, hey, Google, what's up? Right? We essentially are making a web request, and these are the headers that are being sent. We're saying what the protocol is. We're saying what form of REST is, which I'll get into a little bit more deeply in a second. We're saying the host, and then we're getting a response back. And then you can see down here, we've got the HTML actually coming from the response. So this was funny for me because I have this moment where I'm playing around with these requests, and I realize, like, this stuff is just text. Excellent. All right, I'm going to leave some of these here. If you feel inclined, you can come up and grab them. So this is really funny for me. It's like we've built up all of this jargon for a common language, but none of us bothered to read the dictionary, which is also funny. I don't blame you. It's 88 pages is the HTTP spec. Also, it was only released in 1999, which also kind of blows my mind. I was 9 years old at the time, so I don't think I was reading white papers quite yet, but a few years later, I'm into it. So what I did was I went back and I was like, okay, this is pretty interesting. I'm going to try and just, let's do this in Ruby real quick. That's the language I'm most comfortable with. I just want to see if I can make it happen. And it was fairly straightforward, but I don't know, it didn't, you already got one. But I don't know, this was just starting to feel wrong, right? I'm kind of at this point in my career where I'm like, maybe I've been in the same framework and same stack too long. I'm starting to feel a little bit stale. So in 2018, I was introduced to Bill Kennedy and Bill Kennedy's Ultimate Go course. I flew to Miami, and Bill says to me, "How long did it take you to get here?" And I said, about 18 hours. He says, "Man, I could be in India for that." But the thing is I started to see the unknown unknowns. It really opened me up by using Go. I was starting to have some of those gaps in my knowledge filled in from moving away from computer science, and I started to see the engineering decisions that were being made for me. I haven't been engineering. I haven't been thinking about the engineering cost. Rails has been doing this stuff for me for so long that I'm not even sure what's happening anymore. So I wanted to start looking at, like, what does it take to build a web stack, and what do we even consider a web server to be? So how does this work in Go, and what are the costs? And we've already seen that a basic web server, you send a request, you get a response. So here was the Go equivalent. It was a fairly short example. We can go ahead and run that real quick. So I'm gonna open this up. All right, so we've got 18 lines of code to build a basic web server. Let's go ahead and we'll make a request. Oh, actually, I guess it helps if you run it. Okay, so here we go. We've now built a basic web server in Go. I was kind of blown away. This was really easy. This sort of came back to this idea that we're sending text back and forth, but now that we have jargon, we can build tools on top of that jargon to actually make things happen. So again, we send our headers and our request, and we have the server set up to respond to that request. And here's the hello world down here at the bottom, which in this case is the body. So let's check that out on a web browser real quick. And there we go. We've got our hello world. Yeah, not too bad. Okay, so that's a really basic example, but what do we actually consider a web server? I would say that the things I was taking for granted using Rails were templating, routing, which Kaylin, I hear, gave a phenomenal example of while I was finishing my slides, and then of course the database connections. So, no, it's not a bear. That's a common misnomer, but I'll give you a sticker anyway. So let's take a quick look at an example of serving some files. And I'm going to skip ahead just a little bit. But when we're serving files, I oftentimes think we've got a lot going on in these templates, and so some of the difficult pieces can be things like where do we store our files, right? Where are we going to store some of our style sheets? Where are we going to store our JavaScript? And like beyond that, how do we want to break our templates out so that we can manage about the code? So let's walk through this, and I'll kind of show you what's going on here. So this is our entry point for the web server that we're building, and I've introduced a couple of new things. Kaylin went over multiplexing and routing, so I'm going to skip over that. But essentially what we're doing is we're putting together a new router to handle responding to web requests, and then we are going to serve those files. So let's hop out of here. And we're going to spin this up. Whoop. All right. So let's look at what's going on, right? Essentially, we've got our basic web server, we've got some templates set, and we've got a handful of posts. And so within those posts, we've got some templates. So we've got our main layout file, and what this is pretty straightforward HTML, just basic. We're letting the browser kind of go through and fill some things in for us, and then we're linking to our style sheets, which we can make another request to. Oh, maybe not. What's that? Oh, thank you. Oh, the old live typo. Ugh. All right, so we can see, we're serving this stuff directly from here, and let's see, did I lose that? Sorry. Okay, so here's what's going on, right? We're saying we're going to serve anything that's in the assets folder, and we're just going to provide that directly up. From here, I've got a route, and what we're going to do there is actually just forward that to sort of the index of the post so we can look at all of those. And this goes back to one of the things that Rails was doing for me, which is handling representational state transfer, or REST. So again, this was coined the first idea was in 1994. It was actually published in 1999. But the idea of it is it's stateless. You don't need to maintain a connection. This allows us to browse between pages on a web server. It was originally called the HTTP object model, but they thought that would be too confusing with the HTTP RFC spec. So let's talk real quick about some basic URLs. So the first thing we've got is the scheme, which basically says, is this HTTP, HTTP encrypted, HTTPS, or FTP. The next thing is you can include some user info, the host and the port, and then the last pieces on the back of that are the path. And so this is important because I didn't realize most of this stuff hadn't been standardized until fairly recently. So what I wanted to do was basically get away from all of this automation and build some templating and some tooling just from scratch using Go without a ton of extra stuff added in for me. And so when we're looking at these routes, that's what we're following. We've got our index, which just shows all of our posts. We've got a new posts route, and then we've got a posts create. And so we are going to scroll up and we can check out the posts route. And what we're going to do is we're going to build a view. And I've made a couple of pieces of tooling in here, or a couple utilities that basically allow us to auto-generate these paths. And some of the reason behind this is that when I was using Rails, some of the things that I really liked was that this convention over configuration would give you free template rendering, essentially. If you named a template the right thing, it would automatically load it in there for you. And so I thought, okay, well, that's great, but all of that's hidden from me. So I'd like to do that in more of a straightforward way. So essentially with templates, you can do some nesting. So I've got my main template, which refers to a navigation template. And then within there, we have the actual template for the thing that I want to look at. So as we go through this, we've got our main layout template. I've got a navigation template and then the content template. So the navigation, fairly straightforward. It's just a couple of anchors and a horizontal line. And then we've actually got the posts, which is how we're generating our list. So when we generate when we actually pull up what those posts are, essentially, this is just basic HTML that's being done for us. So that's pretty handy. At this point, we're still adding in quite a few routes, only at 172 lines, where one of the issues I was running into with Rails was I'm burying all of these dependencies pretty deep. I'm using these larger libraries that handle auto-loading, and that stuff was starting to get tedious, and it just seemed like it was overwhelming. And sometimes I just wanted to be able to access these things directly. So I templated out all these routes, and I'm thinking, okay, that's great, right? I've got my post model, and I created a few of those. I created a find post by ID so that I can actually pass in a specific post. And we can show that here. And so this is going to load that one specific one for me. So already within this short bunch of code, I've got like a pretty decent template for stubbing out some a basic web server functionality. So the next thing I wanted to do was start to look into actually connecting to a database. And that's actually not too much more tricky. I was really surprised about this. But essentially, I can use this same paradigm and a lot of the same templating and add in a little bit more boilerplate code. And this allows me to get rid of an ORM. Raise your hands if you're familiar with an ORM. Okay, cool. So ORMs, as I'm sure you know, can either be your friend or they can be a terrible, terrible nightmare in the odd case that you actually need to do kind of a strange query or a bunch of joins. And so, this was something I've been wondering for a while recently, like, is it actually necessary to use an ORM? If I'm putting together a really simple web service, like, maybe I just want to throw out some SQL. Half the time I'm debugging an ORM in SQL Pro or a direct SQL client anyway. So, I said, okay, well, let's skip the ORM for a second and let's just put in some basic connections to a database. So I'm using SQLite, which is a flat file, which is great because now I've removed the dependency for running something like Postgres or MySQL in the background, and I can just have that local on my machine. But the other thing that I get by switching to SQLite is that it makes it portable. So this package of code can now move between development environments, and the only thing you need to have is Go 113, and we're good to go. So that was an unintended benefit of doing it this way and kind of staying away from a lot of this stuff. And the other thing was that I can encapsulate everything directly in here. So I don't need to worry about database configuration files with SQLite because I can write that file directly to the disk. So what I'm doing here is within this main, I'm defining where posts.db is. So I'm going to put that in the project root. I'm going to create a post.db file. I'm going to make sure that one doesn't already exist. And then I'm going to open that file and seed it. So when we're doing the seed, we're just going to create the table with a title and a body, and then insert a basic post. And now, when we actually go to the /posts, we can view that. So we're going to step back out. Uh-oh. Ooh, all right. So we'll step back for a second. I must have made some last-minute changes. But essentially, what we're able to do now is have a straightforward connection to the database. And this has been really cool because now I've got an entire, I'm not going to call it a framework because I can just browse through and see what all of the code is doing at any point in time. I'm not encapsulating, I'm not hiding anything. All of this is in one file, and the only thing I've done is really build some templating logic and kind of build around the normal accepted conventions around REST and HTTP. So the total code behind all of this is only 244 lines. And this was really interesting to me because, previously I'm looking at large frameworks and I'm kind of getting bogged down and I feel like my development's getting slower and, I'm coming back and forth between projects and I'm really just starting to think, man, like plain SQL sounds nice right now. I know an ORM is nice and it sort of makes things easy at the time, but I stumbled upon this proverb, which is a little copying is better than a little dependency. How many of you have added a dependency to your project and then tried to build it and it worked, and then moved to another machine and it broke? Okay, that's nowhere near enough hands. You're lying. But here's the thing, is with a little copying is better than a little dependency because everything is there. You don't need to go searching through dependencies or worrying that the wrong version of a dependency got cached or it's specified in a config file. You only need to use what you need. So for me and the developer group back home, teaching and using Go gave us all a common language to talk about engineering together. It gave us all a common language to understand engineering trade-offs and engineering costs. And it gave all of us in this room a way to connect about the things that we're interested in and the engineering costs that we deal with on a regular basis. So removing abstraction and adding transparency, I would say, is actually driving us closer together as a community. It allows us to build projects and share with each other a lot more easily, and it gives us the ability to have a dictionary that is not 88 pages. All right. My name is Jeff. You can find me at JeffLevin3 on Twitter and check out some of the AK Dev Alliance stuff. If you ever want to come to Alaska, shoot a tweet. You know, we're totally open to having people up, and hopefully someday we'll have GopherCon Alaska. So thanks everybody for sticking with me until 4:30, and I'll see you all tomorrow.